So, my name is Tim Szigeti. I'm with the IoT team. I'm a principal technical marketing engineer. I've recently joined the IoT team. I've spent the last 20 years at Cisco in enterprise networking. We were just talking with Orlando. I did a lot of work with QoS, and in the last 5 years I've been working on DNA as an architect, and specifically DNA assurance is where I've done a lot of work. And now as we're extending the enterprise, this is an explosive place to be in IoT. So I'm really looking forward to sharing with the announcements that we've been making the last couple of days and what that actually means to our customers and the use cases we can enable with some of the new platforms, technologies, and management solutions. So that's what I'm hoping to cover today. I invite questions, I invite the dialogue. We put a lot of time aside just to accommodate that. That's a lesson I've learned the hard way. I didn't spend enough time doing that last time. So let me just quickly sign out. Pardon me. I'm not even sure where I'm getting these WebEx Teams, but I thought I had closed all my WebEx Teams and signed out, but oh, you know what? I think I'm just going to waste more time. Yeah, I thought I closed it. Okay, anyways, let me get going. The title I've chosen today is a nice, short, abbreviated, easy to remember title, and so I'm going to have to read it. So, because the easiest way to rob a casino is through a fish tank, you need intent-based networking at your IoT edge. Okay, so what am I talking about here? We all know that the easiest way to rob a casino is to get 10 of your friends together with an elaborate con full of, misdirection and double fakes and a little action, a little romance, and then boom, you've got it all. You walk away with hundreds of millions of dollars, right? So we all know this to be true. But actually, there is an easier way to rob a casino. And all you really need to do is command and control the thermostat that's located in the fish tank in the front lobby of the casino, and then you can access their network, start using that as a foothold, start probing their networks, and you're going to walk away with all the confidential customer data of the high rollers of the casino. It's worth quite a bit of Bitcoin for you there. So, IoT really exponentially expands the threat vector of attacks. And this is what we're seeing over and over again. For instance, it's not just a matter of using IoT devices to launch attacks, but even a study that was published yesterday by Pepper.com, I believe. They took 12 different devices, IoT devices off the shelf from Walmart, stuff that you can buy yourself. And they noticed that within a few hours of them using them, their customer data started appearing all over the world. So they're not guarding your privacy, they're giving it away. So not only can they be used as an attack launch vector, but also for disseminating what you think is private. So some very interesting paradigms. But there's actually even more threats. If you think about this, can a hacker freeze you? Well, that's what the tenants of 2 entire apartment buildings, not apartments, 2 apartment buildings in a little town in Finland experienced in November. I've never been to Finland, especially not in November, but from what I've read, it gets pretty darn cold. And imagine your entire apartment building, no heat, no hot water, only cold showers. And how long is this going to go on? And then what are you going to do? And they had to take a whole week this went on, because of a DOS attack on their heating, ventilation, air conditioning system, and that control their temperatures. A hacker. It's crazy what they can do. And that's not even it. There's more. You think that somebody can take control of your car as you're driving it? Well, if you're driving a Toyota Prius, a Ford Escape, a Jeep Cherokee, and many other vehicles, absolutely they can. Over the air. You could be driving at 120 kilometers per hour like this volunteer driver was doing. And then suddenly the air conditioning turns on and off, the stereo turns on and off, the wipers go on and off. He's laughing, oh, that's kind of cute. But then they started controlling the brake and the accelerator, and he ends up in a ditch. That's scary stuff. And can you imagine when that's done en masse, a controlled botnet attack using actual cars? That's a mind-blowing sci-fi type of experience that you could very easily achieve, and it's possible today. It's been proven. Not only that, here's, I think, the scariest. A hacker can kill you. You as an individual person. This has been verified by the FDA that says, you know what, if you're wearing a certain type of pacemaker, that pacemaker has vulnerabilities that can allow someone to take control of that and to increase your pulse rate to the point where you could have a heart attack at somebody's whim. Now that scares the garbage out of me. But this is the world we live in. Everything is coming online. There's a lot of value to these things coming online because then you can sense things and centrally control them and actuate and cause change in the physical world from the virtual. But if it's not done securely, you can see that the benefit is incredibly outweighed by the risk and the cost. Like that thermostat in the fish tank. Who did that benefit? The guy that looks after the fishes so he wouldn't have to go and check on it every so often? What did that cost the casino? Or for instance, you probably remember that Target in 2013, they had an attack and a security breach that cost 110 million customers confidential data, point of sale information to be breached and exfiltrated from their network. And the attack vector was through the heating, ventilation, air conditioning systems. So yes, it's nice to have these things online, and then you can automate when the temperatures comes on and comes off. But what's the risk of doing so? Connectivity alone is not enough. Or there's been banks that have been, infiltrated through their security cameras and so on and so forth. Many, many examples. Okay?
And I think there are two factors. One is the poor implementations by all the vendors. Just drop something, sell it for a few bucks. The second thing, most of these IoT devices are handled by non-IT persons, janitors, I don't know, fish tank people, and so on. Yeah, so
yeah.
That's a double risk. Yeah.
Dominic, very good comments. You're spot on. And because you're the first one to break the ice, I'm going to share with you something. This is a book. Where should I put it? Right here. That came off the press 3 days ago. We just finished writing it. It's a Cisco Digital Network Architecture, and it's been signed by all 4 authors, myself, David Zacks, who's going to come in here immediately after me. He blows me away. He's also from Vancouver, Canada. That guy's brain is absolutely amazing. Matt Faulkner, another distinguished TME, and Simone Arena, my friend from Italy. So they've signed all of this, and I'd like to present that to you.
Great. Something to read on the flight.
Something to read. Don't get a backache from carrying it. I know nobody actually has physical books anymore, but it's, like I say, it's been signed. We can't sign a virtual copy for you, but please.
I love physical books.
Good. Good. I'm glad. So, well, it's in his name now, so it's all good. So you've touched on a lot of points. Yes, it's OT people that leverage these devices, and they're not even thinking about security implementations. And unless the IT people have got policies in place and protocols like .1x or other things like that, then as long as they have connectivity, they're thinking, hey, look at the time I'm going to save, but at the cost to the company, it's going to be staggering.
Yeah, and another thing is a lot of these things have no way of patching anyhow, yeah? They are one-time deployments, and even if there are known vulnerabilities, there's nothing what you can do.
Very good. So speak of the devil, we just mentioned Dave Zacks, just walked into the room. We're in the presence of greatness. Very good. Just now, yeah, right. Just now. Okay, so then the starting point for every journey, I think you'd agree with me, if you're going to be an IoT, you've got to start not just with connectivity. That's not enough. These examples, I hope, demonstrate that case. But it has to be secure connectivity to really then get the benefit of what you're looking to achieve from the IoT devices, the sensors, the actuators, and every type, but to contribute to your business transformation. But it has to be done securely. Would you guys agree? Okay, good. Now, when we see people and customers on their IoT journey, we see at least 3 broad phases. First, they'll just say, hey, let's start connecting things. Let's just get them online. We're not even necessarily sure of what we're going to do with them, But let's get them connected. After they're securely connected, then they start realizing, OK, this has got a lot of potential. Now they start doing things like remote monitoring or controlling. And then they're like, oh, there's a ton of data available to us. Let's start using that data in some very real ways. So let me give you an example. I live in Vancouver, BC, as does Dave. And this is a hotbed of IoT right now. We have a distinguished systems engineer, a good friend of mine, Rob Barton. He's been spearheading a number of projects in the area, such as with our utility company, BC Hydro. This was one of the first in the world to deploy smart meters. 2 million smart meters across the province to avoid having to read a meter, manually over and over. Now they're read and updated every hour and ingested, and so you know exactly when the power is used. Or, for instance, at our local university, University of British Columbia, they did a really cool project to interface location-based Wi-Fi analytics with the heating, ventilation, air conditioning systems. As some of you probably know, it gets cold in Canada, and so it costs a lot to heat our buildings. So in these old buildings, particularly, that aren't energy efficient, that's a very expensive proposition if you're heating rooms that there are no students in. But rather than putting things on timers or some other solution, because if it's timer-based, if there's an ad hoc group of students that come into a room, you don't know that, and they may not have the access to the thermostats. But by Wi-Fi analytics, you know when people have walked into the room because their Wi-Fi devices have associated with the access point, and then that signals to the HVAC system, OK, turn up the heat. There's people in here. And as the people leave, it's like, oh, we know that. We can turn that down. They're saving $200,000 a year with that solution. Another is the bus company. So the bus company, the transit company, they just wanted to start connecting. So they say, let's give our passengers Wi-Fi. When they're sitting on the bus, they can do their Wi-Fi. And that was the thinking. That's their first step. But very quickly, they already have 5 networks on the bus. They have a network that's dedicated to monitoring the mechanics of the bus. The odometers, the fluid levels, the RPMs, the mileage, and all of these other things, the mechanics. They have another that's monitoring the fare and ticketing systems, so when people pay and scan their badges. Another network that's monitoring the people counters, when people come off, when people get off. Another network that's monitoring IP video surveillance to keep the buses, giving them good physical security. And that video surveillance, in fact, they have an inventive solution. They don't want to stream that over LTE back to the control center, but they have workgroup bridging. When the bus drives into the depot at night, connects to Wi-Fi, now all that footage is uploaded. It's very cost efficient and everything. And then finally, the original intent wireless network for the passengers. So you see how it starts to evolve. It's like now that we've connected something, we've got all these new possibilities. And also because every one of these routers has GPS, now what they're doing is that they have a huge control center where you can see every bus, all 2,000 of them at any point in time where they are, and not just benefits them, but they're like, why don't we export this and share it with our customers so that the customer gets on his little handheld device, and then he can see exactly when the next bus is coming, just like an Uber type of experience. Because it's a very different experience if you're waiting and you know how long you're going to be waiting for versus waiting and you have no idea. It's night and day difference. So the point I'm making is that, and actually then, this is still sparking a lot of conversation. Hey, it's like, what else can we do? Well, we can use this data to extract when are the most busiest routes, and not just relying on anecdotal impressions by the bus driver. We have quantitative data. This is when the most people get on, get off, and if you have, for instance, some login information and say, hey, tell me about yourself as you subscribe to this app, this service that'll update you from the bus. Oh, your name is, well, you don't need your name, but hey, I'm so-and-so old and this and that. Then we could even do, digital signage on the bus for ads that could be custom tailored to the people that are on it, or at the bus stop. There's just so much possibility once these things get online. So that's how we see these type of phases actually, translating into case studies. Does that make sense? It's kind of cool. It's like so much potential once things are connected. So the whole goal here is what we want to do is to extend the enterprise to say, okay, yes, we have a lot of networking gear in carpeted spaces, in our data centers, in our offices, and so on and so forth. But there's a lot of other places that could benefit from connectivity. Almost every type of company, including our own, has some sort of warehousing. And there, the temperatures aren't controlled. It's a very harsh environment that way. Or distribution centers or parking lots to keep them safe. Everybody's concerned about physical safety. You hear random violence breaking out place after place. Anything you can do to address those concerns and make things a bit safer is very top of mind. But then there's also different, like there could be remote assets. We just talked about buses that are moving around, how they can benefit, or tracking delivery trucks or other things like that, or kiosks. You have ATMs from a bank that are located all over. They need to have secure connectivity back for the transactions they're processing. And then industry-specific plays. And there's just an infinite variation of these. Manufacturing, energy, utilities, airports, so the list, we did the Port of Rotterdam not too long ago. So just so much possibilities when these things start to be connected. There's 3 big challenges, okay? We've already been talking at length about the challenge of security. The other big challenge is that so many of these, they're all brownfield. And some of them are brownfield, like 40, 50-year technology. Programmable logic controllers that have been around for decades, and then they don't speak and never will speak IP and Ethernet and things like that. So how do we get information from those onto our network and then start actually benefiting from some of this material or from some of this data? And then finally, scalability. There are literally billions of devices coming online every year. According to some studies, it's closer to 10 billion devices coming online. So all depends who's estimating. It's very hard to estimate, but it's big. It's a lot of number. It's big numbers. So this is what I'm going to be emphasizing now as I start talking about the products we launched yesterday, that how these meet the needs for flexibility. Brownfield deployments. There is no one-size-fits-all use case for IoT. There's so many as we've been covering. Security, how they meet the needs for security. And we've started with that because that's a top-of-mind concern. And then finally, scalability. How do we just manage these? Because it's just going to become overwhelming very, very quickly. So with that, I want to share what we announced yesterday at the keynote, what Liz Santoni, our Senior Vice President, was sharing, is that we have a couple new platforms that I want to feature. And I'm told that if I put them here, they can be picked up well on the camera. So what I'm going to, as I walk through, I'll demonstrate what we're talking about. Let me know if that's a good placement. Yeah, Ben? OK, excellent. So what's new about these switches and routers? Well, one's a router, a Cisco 1101 IR. It's an ISR router that's been ruggedized. And this is a Cisco Catalyst Industrial Ethernet 3000 series switch, and it's also been ruggedized. Now, what's new about these platforms is that they're running iOS XE. That's the first time we've had platforms that have been made to industrial environments or IoT environments that are running the exact same software that you're running on your Catalyst switches and your regular ISR routers in the other parts of your network. So they have the same programmable interfaces. They have the same features, the same capabilities. And so it's like you can manage them from the same management planes, such as Cisco DNA Center, which I'll be demonstrating for software-defined access on the switches, or Cisco SD-WAN for the router. And that provides you a lot of scalability, because then you don't have to have a separate management platform or solution for bringing them online, managing their software and all their features, and getting assurance data from them, and pushing out policy, and all of these things. So these are the key benefits. But also, and I know that I'm not sure if everyone can see, so I've included some slides that are a little bit of show and tell, but I'll also be demonstrating as I'm talking here. They have a tremendous amount of flexibility. Remember, that was one of the key challenges. There's no one-size-fits-all. So I can extend. If I say you need 8 extra ports, it's kind of like Lego, right? What do I need? I need 8 more copper ports. Super. I need more than that. I need 16. No problem. I'll put that together and I got 16. They could be PoE, they could be non-PoE. I could do the same for fiber. I could also do a mix. Here I have 14 copper PoE and 2 fiber uplinks. And they're all gig-E. And we've never had this in our switches before too. So, you know, we got these speeds, we've got this flexibility, and so a lot of really flexible mixing and matching just with the hardware modules themselves. So similarly, with the Cisco IR 1100 router, let's take a look at that. Some feature data. I'll go through that as I talk through it. We have the router itself, very small form factor. As you see, I'm holding it in the palm of my hand. And then I have modules, like if I want to hot swap a module, maybe I need 3G. Swap, it could be copper WAN module, it could be fiber WAN module, it could be DSL WAN module, all of the standard WAN modules that you have, but you could have 3G, or maybe you want 4G, you swap that out. Maybe when you're ready for 5G, same. Just a hot swap module, there you go. You want redundancy? No problem. Very quick little expansion module. And then now we got redundant uplinks here. So we could have radio redundancy to say, okay, I got a dual LTE connection. Or maybe I want carrier redundancy. One is going to AT&T, one is going to Verizon. So depending on how their coverage areas are, I'll be in range. Even if one of them provides coverage in a given area, and they're active. So this is not a hot standby paradigm. This is dual, always active LTEs that are available. So you're really utilizing the capabilities of these links. Let me talk a little bit about also how the designs for the environmental elements contribute to their flexibility. So let's play some more true or false. What do you think? Can you use a 9300 series switch here? This is like my picture from my backyard in Canada. No, I'm just kidding. Not quite. Not quite. No, did you know that a 9300 switch will not boot up if it's below freezing? It'll freeze. It won't come online at all. This little switch will boot up at minus 40 Celsius or minus 40 Fahrenheit. They happen to be the exact same mark. So you got basically 70 degrees of operating range if you're in the Fahrenheit scale, 40 extra degrees if you're in the Celsius scale. And so you got a lot more flexibility where it goes. Jasper?
How did you do that? What's the difference between the two? Why can that still work at that temperature and this one can't?
Yeah, that's a great question. So it's a lot in the design. This has, first of all, no moving parts like fans. So those things can very much, are heat sensitive. It's convection cooled, and just the hardware engineering, the specifications of the individual electronic components are to specific industry standards that allow them to operate at such low temperatures. And as such, no moving parts either, and shock absorbent, electromagnetic resistant, all of these industrial elements have gone into the hardware engineering of the actual switch. So that's how they achieve that.
So you're saying that the moving parts keep that 9,300?
Moving parts, and I think also the specifications of the individual electronic elements. Okay. There's certain types of industrial specifications that say, if you need to go below zero, you need to have, I don't know the details, but like some additional grades.
Freezing electrolytes in one of the condensators or stuff like that.
Possible like that. I don't know those level of details, but I'm happy if you ping me. I'll get you in touch with an engineer that will have that. Yeah, it's interesting stuff.
Oh, okay.
No, even silicon is rated commercial, industry, military.
Okay.
Ivan, thanks for getting my back. Okay, but it's not going to work there. But this little switch definitely will. Yes?
How was it discovered that it's not going to work? Was there a case?
Oh, we do a test. We do extensive testing, and like to meet industry certifications, the testing process is laborious, exhaustive, and it takes a long time. So, and that's why. And this is, I'm pulling these stats from the data sheets, so all of these numbers are certified and tested. And that's how we get those numbers out. But very good question. So, if you want to monitor your pipeline, you can support that kind of use case. True or false? Do you think that one of our routers will work in a desert solar generation plant? You know, these things get really, really hot. It's like, no, it's going to be well beyond. You see, like our typical platforms, our routers and our switches, they're meant to live a very cushy lifestyle in an air-conditioned data center, right? That's secure and, you know, raised floors with good ventilation. They live a very good life compared to their bastard cousins, if you will. So these guys get put out in the harshest environments. They're not really, you know, living quite in the big fancy house, but they survive. In fact, there's no place on Earth, the face of the Earth, that you can't put this little router and it can function. With the exception,
put it in the sun because it's
put it in the sun? Okay. Well, actually, Lauren, yesterday I did a podcast, and she goes, "What about in a volcano that's like, you know, flowing lava?" And I'm like, "Oh my God, Lauren, thanks for the, you know, the exception and to my logic and blowing me up there." But anyway, so other than, let's say, flowing lava in a volcano, you know, the highest recorded temperature on the face of the planet, 56.7. This box.
In shadow.
What?
In shadow.
In shadow. And this box goes up to 60. This one goes up to 75. So if you're like, you know, monitoring traffic in Las Vegas desert or, you know, in a solar factory or wherever you are like that, you have those kind of options available to you. Sorry, my formatting's off. If you need to run a switch inside a medical facility in a Himalayan base camp, you can do that with these switches. You know, so again, tremendous flexibility just also with altitude. You can't get above 3,000 feet with regular routers.
Can I have a tech contract to the Mount Everest?
Well, actually, I was hoping not to say, I wanted to say Mount Everest, but I deliberately said Himalayan because Mount Everest is an exception. Their base camp is at 17,000 feet. But if I make it more general, some of the other mountains, most of the other mountains are 15 or less. But you're absolutely right. So Everest is an exception. So you guys are catching all my exceptions.
So where's the trick there? Air density for cooling?
Probably air density.
Again, I don't know the specifics. I just know it's been engineered to that. I'll find that out for you, Ivan. That's a really good question. What do you think takes more power? Power is often a premium in these locations. If it's such a remote location, maybe monitoring sensors, you're not going to have power lines available to you. Or if it's on a vehicle that's moving around, you want to be very considerate of the power draw. What do you think takes more power?
Depends on the light bulb.
Depends on the light bulb. You guys are good, man. I can't pull nothing. Okay, let's say a regular incandescent light bulb, a traditional one that we all grew up with, that are rapidly being replaced, they took 100 watts. This is 1/10 of that power draw. And yet it can do all of these functions, SD-WAN, IPsec, traffic routing, PFR, app recognition. And it's just like LTE, dual LTE. So
Quality of service?
Quality of service. It does quality of service as well. Absolutely. Very good. So let's do some demo. Any questions before we start?
I have one question. Did you also test movement? So
yeah.
I'm thinking about if this is, I don't know, on top of a tank or something.
Yeah. I did that deliberately, though, by the way. You know what I actually wanted to do, Dominic? I said, why don't we, you ever go to these hardware stores or paint stores and you say, I want this color paint, and they go to a computer and then they get those little eyedroppers and they put a few drops into a white bucket and they put it into a shaker? I'm like, I want to buy one of those shakers, bring it to Tech Field Day, put it on the table while it's running pings through it. I wasn't given approval or budget or anything. I thought that would have been really cool. But they are vibration resistant, you know,
so
and then
earthquake. No worries.
I don't know. I think that would depend on the earthquake, but I think you're getting the point. So let me go through some of the demos and just show how you can use, you know, existing management platforms. And I'll keep, you know, I really want to keep on speaking to this theme of flexibility, security, and scalability. So let's take a switch over here. So we have DNA Center, right? So with DNA Center, it supports both of these platforms, our IE3000 series switches, also our IR1101 rugged routers. And so let's just start with the basics. Getting a device online. Well, because they're running iOS XE, that means they also have the PNP agent. So you have the ability to do zero-touch deployments. The device boots up, it gets its IP address, and within the DHCP option 43, it tells it, okay, where the PNP server is. It goes there, it talks to it, and then it identifies itself with its digital certs and serial numbers, so you don't have a rogue device being replaced. And this is tremendously important. I'll tell you why. Here, you might notice I'm wearing my badge. This is what gives me access to my regular Cisco routers and switches, right? In the data center, provided yeah, by all means, please pass them around. Brilliant. So this is my badge if I want to access a regular switch. You want to see, there's a very special badge for accessing IoT switches and routers. You want to see it?
Yeah.
Who wants to see that badge? And I walked in here with it today. This is exactly how I walked in to the stadium. Carried this from Canada. This is my IoT badge to access my routers and switches. It's handy dandy crowbar, $17 from Home Depot the day before I left to come here. Why it's so shiny and new and not hacked up. Somebody's like, that doesn't look bad or dangerous at all. You should go whack things with it to put some nicks and dents in it. But this will give me access to all my devices. So if I'm a rogue actor, I just basically pry open a cabinet and I have access to that. Maybe I want to take that, disconnect that network device, put my own rogue device in, and now I've got a foothold into the network. Or maybe I want to start tampering with the software that's on that boot image. All of these things, this is how simple it is. I have a degree of physical security risk in IoT that is not present in the carpeted workspace. By the way, I can't resist but making a comment about the security here, right?
Yeah.
So for the first time ever, and I've been doing these for what, close to 20 years, I think, these type of conferences, all you ever needed was a badge to come in, right? You have one of these badges and people let you in. And now for the first time, they're saying, hey, show us your government ID as well as your badge. So they look at my government ID, they look at my badge, and I'm walking around with a crowbar hanging out of my bag, and they're like, yeah, go on in.
Yeah.
So it's like it doesn't really matter what kind of potential weapons I bring into the place as long as they know who I am. And so like whatever mayhem I unleash, they'll know the name to put at the bottom of the live feed. And it's just like, that's great security.
I was talking about the same thing with all of
Yeah? Okay, very good. So the point I'm making.
Get that through TSA.
Get that through TSA, check baggage, yeah, exactly. But, okay, so I need a secure way of bringing my devices online. PNP provides that because of the digital signing and encrypted communications in the onboarding process. Not only that, but even things for software image management. It's like, again, how do I protect my software from getting hijacked when somebody can get physical access to the console of any one of these devices and start, uploading whatever tampered software they want? Well, with Image Repository in DNA Center, I have all of this digitally signed images. There's actually 10 different integrity verification tests that go on before I push an image out. I can tag an image as golden, so I'm up to the latest release with all the security patches, and I push that out on all devices without missing any and having any holes and gaps in my infrastructure software. And so again, security, scalability, the benefit of all the programmable interfaces in the platforms as well as being managed centrally by DNA Center. Not only that, but if I have all the benefits of assurance as well. So I can see these devices in DNA Center, I can see their health, I can see what's going on. If I have to troubleshoot, maybe somebody suddenly reports that a security camera in a parking lot has gone down. Okay, well, who do we call? Do we call a person to go, a technician that specializes in the camera, or is it the network that somehow got damaged or something happened to it? I can do path trace through assurance all the way to my security cameras and see if it's a network issue, or if it's not a network issue, then I'll send the tech out. Maybe somebody bashed it with one of these, and it's like, okay, that's not going to be something a network technician can solve. Again, the benefits of using a single pane of glass like assurance. But in all honesty, I think the most compelling benefit is software-defined access. So let's talk a little bit about that for IoT use case. And I think I'll even make the statement, I think that software-defined access is one of the best, if not the best, use case. I'm sorry, that IoT is one of the best use cases for software-defined access. And I'll show you why. So earlier I talked about the network attacks for Target, came in through the HVAC, the casino came in through the thermometer, the building in Finland where they DDoS the thermostats in the buildings, so on and so forth. All of those network attacks could be prevented with just a simple macro segmentation policy in SDA. Here's how simple it would be. You say IoT macro segment, give the policy a name, and then say, okay, what should go in there? Well, badge readers are an IoT device. And the thing with IoT devices is they don't authenticate to the network like ordinary devices like our laptops and our phones. They're typically not running 802.1x. There are no usernames and passwords to be entered and challenged and checked against an authentication server. These devices just boot up and they come and they start doing their thing. There's very little thought to many of these to have security. For instance, we do in our own security cameras, we have .1x and we have digital certs, but there's a lot of security cameras on the market that don't. And so the very first step, mandatory recommended first step, I would recommend to anyone doing IoT is to segment the IoT network. A logical separation of all these devices. And you see how easy I did that? I'm just dragging the groups for these devices from ICE, and I'm just saying put them in a virtual network on their own, and I click Save. That step alone would have kept the customer data. I didn't like the name that I chose. I'm just going to shorten that name and save it. That alone would have prevented all that data breach at Target or the casino or all these other things that I mentioned. Simple step. And this is complete. There are no holes in this policy because you're managing the network as a single programmable entity from a centralized automation platform like DNA Center. But not only that, I can go one level further. For instance, besides segmentation, I can also do explicit policy based on the scalable group tags. Okay, so I have my IoT devices, for example, and I'm going to make a specific micro-segmentation policy. And the reason I'd want to do this is because the very first thing, here I just click Add Policy, I give my policy a name, microsegment, and I'm going to say, you know what? In that virtual network that I've created, just for IoT devices, I want to make sure that different types of IoT devices don't communicate with each other. Because as we talked about in these attacks, what we've seen is that once a device is commanded and controlled, it will start to probe everything it can talk to for vulnerabilities. Do badge readers ever need to talk to HVAC systems or vice versa, or to security cameras? So even though these are in the same virtual network, and virtual networks by definition and default are completely isolated. They're isolated from the other networks in my organization. They're isolated from the internet. You can at the firewall control any policies that might route between them, but that's very specific and one place to administer, but you don't have to do that on every single switch with thousands of lines of access lists and provisioning all these VLANs, and you don't have to stretch VLANs across multiple switches to achieve this type of separation, which leaves you vulnerable to broadcast storms and all the wonders that they create. But you can do this type of segmentation very granular and very easily. You see, it's an intent-based expression. I'm just saying, don't let these talk to that. Even though they're in the same logical network, there's no business for these type of IoT devices to talk to that. Very easy and simple to set up and then to deploy. Is that cool? I think it's really cool. I'm sorry, I get excited about these things. The other thing I also want to show is that our router, I'm not sure where it went around, but our router too is fully managed by our SD-WAN solution. So any SD-WAN use case that you have, whether it's a branch or it's a kiosk or whether it's remote assets that's moving around with VPNing here, you see we have 1101 and manage everything you can do with SD-WAN, then you can also then do it with our ruggedized platform here. So those are some of the key points I wanted to share with our latest products and how they can benefit the enterprise. Basically, here's the key takeaways I'd like to just double click on. What we're doing for the first time is extending an intent-based network all the way to the IoT edge. That's our key marketing message. So, we have ACI in the data center. And then, that's very much tuned to the needs of a data center. It has a very consistent topology, typically spine and leaf. You don't have any mobility requirements in the data center. There aren't users that are moving around. Those machines are fixed. The VMs can be redistributed, but the physical topology and the connections and the routing, that's all very fixed. In the enterprise, we have a different domain. We have, DNA center. And there's many different topologies in the enterprise. And you have mobility requirements. You got, different types of, 3-tier, 2-tier campus network infrastructures, and so on and so forth. And then that would be run by DNA Center. But these two talk to each other now. And now you can also extend your intent all the way to the IoT edge. So a really efficient way to scale, to secure a central place of policy management, and then spreading it end-to-end throughout your enterprise. We have over 40,000 customers also already using our IoT. So we're not just providing them platforms, but also we've been providing Cisco validated design guides. I think you're familiar with these as well, where we do exhaustive testing and based on real customer deployments. And we're tailoring these solutions, not just for the network, but the whole solution. How does our network, for instance, connect and integrate and speak protocols of industry like Profinet and SCADA and so on and so forth that are managing Rockwell PLCs or Siemens IoT devices and so on and so forth to really allow for that comprehensive, the customer can build it from soup to nuts and not just the networking part, and then he has to go to somewhere else to figure out how to do the rest. And finally, with programmable interfaces, well, this is a world that DevNet thrives in. So we are partnering very closely with DevNet to set up learning, to set up sandboxes, to set up ISV support, et cetera. So we definitely want people to take advantage of the many APIs now that we have available through these platforms. That's all I have for you today. That's what I wanted to share. Hopefully found some value from that. And if there's any further questions, I'm happy to take them. But if not, Dominic, please.
Just a quick
I was told to leave lots of time.
Last year we heard also here about this low bandwidth implementation.
Yes.
Do you think also to bring this to this platform? Some low bandwidth Wi-Fi connectivity?
Yeah, are you referring to LoRaWAN?
Yeah.
Okay, so I invite you to come to the world of solutions and take a look at the LoRaWAN, for instance, antennas, and they're about this big, and the masts on them are that big and that thick. Okay. So they can definitely connect to the router.
Will be always an extra.
Yeah, just the physicality of an antenna like that. But then you could also have different transceivers, receivers, on smaller devices.
And last question for me from the module, how do you do it with antennas? You have external antennas, how do you? Yeah,
it's typically these antennas have Ethernet connections, so you could just connect them through those into the front panel of the routers.
Okay.
Yeah, but really good questions.